Hello, Peter here. Okay, in this episode we will start implementing the point lights feature in the SDL component. But first I need to correct a small bug from the last episode, and that was in the SDL level data actor. I connected the set of the whole tick to the set of the directional light instead of to the completed pin of the for each loop. It should be like this. You wouldn't have noticed this error if you are not dependent on the initialization delay feature. But still, it's better to do it right, and also we will get back here and have to change it anyway. So for now, compile this and save. I can close this window. I also forgot to do something in the set directional light function in our SDL component. So let's fix that. Go to the set directional light function, and this was the line trace for objects. Now make sure trace complex is checked. Again, in my level that doesn't matter at all because everything is simple there, but in your level it might be a difference. It just becomes better. So let's compile and save this as well, because the very first thing we need to do is to go to our materials folder, and here we need to expand our MSDL template. Because now we're going to add our point lights here. So any light that we are adding is basically a new section of this, what I've now selected. You have a normal, a color, and a call to the set light, the MF set light function. I chose to call these things DL normal, DL color, direct light, and I will now create the point light normal and point light color. And because I want the object to support two point lights simultaneously, I will call them PL1 normal and PL1 color, and PL2 normal and PL2 color. But of course you don't need to do that. If you want to be more flexible in your component functions, you can just call them normal 1, color 1, normal, and so on. But I like to have it in this case slightly more fixed. So I will create these things quickly for you so we don't waste time with that. Right, so that is how it looks now. I simply copied that section, duplicated it twice, and renamed the parameters. If you duplicate the function, for some reason it doesn't put the v3 behind it, that's why it looks slightly different. But it is actually the same call, so no worries there. I then add them together and then add that with the result of the other one. So this is our new template. And now we can immediately select this whole new bit and copy it, because we also need to change our test material. This was just a template that we used to copy from. So here we only had this. So let's paste our new stuff in. And instead of going straight there, we now have to go there, and from this add we go in there. I can drag this one a bit to the side. Now we also have to hook up our diffuse texture, which is the texture sample in this tool. So it needs to be there. And there. So now this material is ready for the 2 point lights. Okay, let's save this one, and then we can close the material editor window. Yes, we want that. Well, it still doesn't seem to be saved. Save. Okay, all done. Okay, now we return to our SDL level data actor. Here we need to get all the point lights in the level. The context of this tutorial is mobile platform projects, so there are no dynamically spawned lights or anything like that. All light is static, so it is perfectly okay to get them all here and now. Let's create an array to store them in. Point lights. The type of that is point light. And then the object reference, and then we need to make that an array. So now we have to break this link again. Just fixed it. But what we are going to do here is to get all actors of class. And the class we're after is of course a point light. Then we will get an array here. So what we can do is set the point lights with that array. And then we hook up the whole tick again. So note, it has to be on the completed pin. We fixed that in the beginning of this episode. And of course that is in our event begin play, right? It's just a setup for all the system. Okay, compile this and save it. And now we can open our SDL component. And let's go to the event graph. And here you see what we have done previously. We have set the ambient light and the directional light. And now the first thing after this is going to be to set the point lights. But because we have multiple lights and we have maybe many point lights in the whole level, we need to have the nearest ones, the nearest 2 ones. And to do that, we're going to create a function. So let's create that function. Get nearest point light. And it is going to take as an input an array of point lights. That is going to be point light array, like so. And the first thing we're going to do is to promote this one to a local variable. And the name for that one is, let's call it new lights. And then we're going to iterate all the point lights in this array. And we're going to do that with a for each loop. So, like that. Now the loop body. Now we need to get all the distances from a light in the array to our object. So let's create an array distances. And the type of that one is float array. So how do we get the distance? Well, from the point light, let's get the point light component. Let's have a bit of space for that. And let's get our world location, and let's subtract that with the world location of the point light component. This one, and let's subtract that, and then we can take vector length of this one, and that is the distance from the object to the point light component. Now what we need to do is to add that to our array. And the item is that one. So now let's hook that up in the loop body here. So what we will create is an array of distances where the indexes or the indices correspond to the indices in the new lights and even in the original one, so that we know the distance of every light. Right, so the next thing we need to do is to find the nearest one. And not only do we need to find it, we need to remove it from our array. So first, the whole loop body will fill up the array with the distances, and then when it is completed, we want to remove the nearest. And the array we're going to remove it from is our new lights array, like so. It is a bit, not so much space. But what index is that? Well, from the distances we can do a min float of array. So the index we want to remove is that one. So now we have removed from the new lights the nearest one. The idea is that we return this new lights as well, so that we can feed it once again into the same function and remove the then nearest light, so that we get the two nearest lights. Okay. So now we can return, add a return node. We need some other stuff done, so we need some space here. Return, add a return node, and now we can have a look at what we're going to return. So the first thing we're going to return is our new array, our array of new lights. So let's call that out point lights. And it's already the right type, but it needs to be an array. Then we're going to return our nearest light. And that is not an array. Then we will return a boolean. And let's call that lit. That basically will say if we are within the reach of that light. And we're going to calculate that in a minute, but it is a boolean. And we want to return the distance of that nearest light. And that is going to be a float. Something like that. Good. Now we need to do some things. The new lights we can already get here and hook up. Now the nearest light we need to retrieve, but we have removed it from the array, so we need to get that one from our original array, and it's a long way off, so I would say let's start using a route node to make this slightly okay, because where we can get the index, that is here. So we need to do a get copy, and that will be the same index, so that will be that one. So then we can hook up our nearest light. Now distance we can also do, only you might have noticed, I didn't speak about it, but it is vector length squared here. I did that with a purpose because square roots are quite expensive if you do them a lot of times, and we only need to compare them here. So I left them squared. But now that we have the right index, in this case, this minimum value, I can now do a square root of. Which is going to be the real distance. Now this one we can hook up to distance. That leaves our Boolean lit. Well, point lights, they have an attenuation radius. So if we, from this point light that we got here, get the point light component and then get the attenuation, get attenuation radius. Now we need to check if we are inside of that. But because I want to give us a bit more control over that, to correct that slightly, to give some adjustment to it, I want to add a new setting under SDL. And let's add the new variable and let's call it point light radius correction. Point light radius correction. That's good. Only it should not be an array, but it is a float, so that's all well. It has to be editable and we need to put it into the category SDL. Now we can drag that one out here. And I want to be this value a percentage, either positive or negative. So what I want to do here is to multiply it float with 0.01 and then add a pin and connect our correction. Now the original attenuation radius we can now add the corrected value to. So if our percentage is 0, nothing will happen. It will just be the original one. But then we can play a bit with that value. Now that we have that, we need to see if our distance is within the attenuation radius. So that would be the real distance. So this one, we need to now see if it is less than or equal this value. And then we have our Boolean lit. So this is our function. Iterate all the new lights, get the distance, get the length squared, so the squared distances to our object, add them to the array, find the minimum of that one, and remove that from our new lights. Also get that particular point light, get the attenuation radius, and see if our distance is within that attenuation radius. That's all the calculation done. So if the next time we call this same function with this new array, the very nearest is now removed from it, and it will remove the second nearest. That's the whole idea of this function. Yeah, so compile it and save it. We can now close this. I think we'll leave it at that for now. In the next episode we will create our setPointLight function and start hooking it up in the SDLTIC event. So see you in the next video. Bye bye. Hello, Peter here again. Just wanted to say thanks for watching this video. Please let me know what you thought of it in the comments. Below there are links to other episodes in the series, and don't forget to subscribe so you are the first to know when the next episode is up. Thanks again for watching, and see you in the next video. Bye!